Okay, this video is going to be reviewing solving logs and we're going to be using our log properties to condense our log expressions down so that we can solve some log equations. So I just want to remind you of your log properties, of course. One of the log properties says that if you have log base b of m times n, so the two things inside of the log are being multiplied, then it can be expanded and you can separate them into their own individual logs with addition. And of course, the property works backwards as well, and we're going to be using it backwards here in just a minute. And so if this property that says multiplication results in addition, then the opposite would also be true. If we have log base b of m divided by n, then division is going to result in each of them being separated into their own log and the logs being separated by subtraction. So multiplication results in addition and division results in subtraction. And then the next law that we're going to be using to solve says that if you have something inside of a log that's being raised to a power, that the power will move down to the front. It's called the product property. And so the n would move down to the front and it now multiplies to the log base b of m. And then the last one, the last property we're going to be using for right now, says that if you have two logs that are equal to each other and their bases are equal to each other, that you can drop the logs and their bases, and whatever is inside of those logs has to be equal to each other. And so those are all the properties that we learned before spring break that we're going to be using to do just a few problems. So if we take those properties and we use them in reverse, because instead of expanding our log expressions, we're going to be condensing them down so that we can solve our log equations. So here's the first problem we're going to try. So on the left side we have two separate logs and they are separated by addition. And so in order to put them back together inside of a single log, that means that those two numbers must have been multiplied together. So this would be the first property, but we're using it in reverse to condense. And that means that we have log base 3 of 14 is equal to log base 3 of x. And now the fourth property on the previous page says that now that these two logs have been set equal to each other and they have equal bases, that means we can drop the logs and bases and whatever is inside of those logs is equal. And so x is equal to 14. Okay. So the next problem that I want to do is also very simple. Looks like this. But I just wanted to remind you that right now on the left side, we're okay. We have a single log. But on the right side, we have this coefficient that we need to deal with. And so the third property says that the coefficient that's in front of this log came from or was originally up at the exponent above the 125. And so that means that before we can drop the logs and the bases, we need to move that exponent back up to where it would have originally been, which would have been up there. And so that means that we have log base 5 of m on the left, and we have log base 5 of 5 on the right. Because remember, 125 to the 1/3 means we're taking the cubed root of 125. And that's why it became a 5. And now we can drop the logs and the bases because they were equal to each other. And so m ends up being equal to 5. Okay. So then the next question would then become, what do you do if you don't have a log on both sides? So we're going to try this equation next. Okay, now I'll give you a second to copy that down. If you have an equation that has a log on one side and it does not have a log on the other side, you have two options. Okay, option one is to remember one of the first things that we did with logs was we used their inverse property to turn them into exponentials. So for example, one of the first sets of notes and worksheets we had you guys do had you do things like, if I gave you this log, it's the way we read this is log base 2 of 16 is equal to 4, and we had you simply convert it to its exponential form. And so some teachers teach the loop-de-loop or lasso method, so you put your lasso around the 2 and you loop around through the numbers, and that tells you what order to put those numbers in. But the other thing you can do is if you are reading the logs to yourselves as a question. So for example, log base 3 of 81, what this log is asking you is it's asking you 3 to what power is 81. And so if we had told you log base 3 of 81 is equal to 4, that's because 3 to the 4th is equal to 81. Okay, and so you can simply take a log and convert it to its exponential form. So that's your first option. The second option is you can attach a log to the right side of this equation. And so if I did that, this is what that would look like. I would simply multiply this right side by log base 4 of 4. And the reason that I would do that is because this log right here is just equal to 1. So I didn't multiply the right side by anything but 1. And it's a log that's got the same base as the left side. So now I'm going to be able to use my property that lets me drop the logs. So if I did that, what would happen is over here on the left side, I would take my 2 and I would move it back up to the exponent where it came from. Over here on the right side now, I would need to do the same thing. I have a 3 in front of this log, so I would need to move it back up to the exponent where it came from. And so that would give me log base 4 of x minus 4 squared on the left side. And if you tried to multiply it out, you would need to make sure you FOILed. And on the right side, we would have log base 4 of 4 cubed. And then we could drop our logs and bases. And so we would have x minus 4 squared on the left side, and we would have 4 cubed on the right side. And so we have x minus 4 squared over here, and 4 cubed is 64. And then to get rid of the squared, we would square root both sides. And so we would have x minus 4 is equal to 8. Normally when you do that, you would want to remember to plus or minus when you square root, but remember we are solving a log equation, and we know that negative numbers don't work when you put them inside of logs. So if you wanted to be on the safe side, you could do the plus or minus when you square root, but then what would end up happening is the negative answer you generate will end up not working in this log equation. And then your last step would be to add the 4, and so you would have x is equal to 12. And of course, x equals 12 does work in this original equation, because if I plugged the 12 in right there, then what I would have is I would have 12 minus 4, which would give me a positive 8 inside of that log, and so we know that it would work. And then the last problem that I want to do is more complicated, just so that we make sure we cover different levels of problems. So we have log base 16 of 9x plus 5 minus log base 16 of x squared minus 1 is equal to 1/2. So we do have a messier log that's going to pop up on the left, and we do have no log on the right. So I'm going to go ahead and I'm just going to multiply the right side by a log. I'm going to attach a log to it. So I'm going to multiply it by log base 16 of 16. So once again, it's got the same base as the other logs, but it's just equal to 1. So I didn't mess up the right side. So now I can use my log properties. So what's going to happen over here on the left is these two logs are separated by subtraction. So I'm going to put these two logs back together with division. So that means the 9x plus 5 is going to be on top, and it's going to get divided by the x squared minus 1. And then over here on the right side, I now have a coefficient in front of my log, so I need to move that back up to the exponent where it came from. And so I have log base 16 of 16 to the 1/2. And of course, 16 to the 1/2 means the square root of 16, because that's what a power of 1/2 is. So you can either turn that into a 4 now, or you can wait until you've dropped the logs. Okay, so I'm going to drop my logs and my bases, and so I will have my 9x plus 5 over x squared minus 1 on the left, and then, as I said, that 16 to that 1/2 is a 4. Okay, now to finish solving this actually just became a quadratic. It doesn't look like a quadratic yet because it's got a big messy fraction in it. So what I'm going to do is I'm going to take this denominator and I'm going to multiply it up to the other side. And so I will have my 9x plus 5 on the left side still. And when I multiply this denominator up to the right side, I need to remember to distribute, because technically what this is 4 times x squared minus 1. So what I have is 9x plus 5 on the left, and I have 4x squared minus 4 on the right. And now that it actually looks like a quadratic, hopefully you would remember that when you want to solve your quadratic, that you want to set it equal to 0 so that you can factor it. So I'm going to move everything over to the right side. And when I do that, I would have 4x squared. I would subtract the 9x to move it over. And then when I subtract the 5 to move it over, I would have a minus 9 on the right side. Now this quadratic does factor. And so if you need to, you could pause the video and you could refresh your memory on your grouping and your other methods for factoring the quadratic. But it does factor. And it factors as 4x plus 3 and x minus 3. And so initially we would get two answers. We would have negative 3/4 from this factor, and we would have positive 3 from this factor. But remember, we are solving a log equation. And so what you would need to do is you would need to take each of these solutions. So if I took this first one and I plugged it in up here for x and in there for x, then what you would figure out is you would have negative numbers inside those logs. And so this answer gets thrown out as extraneous because it doesn't actually work in the original equation. But when you plug the 3 into the original equation, it does work. And so that would be your answer. So that's a very quick refresher on solving log equations by condensing logs and using your log properties. And so what we would like for you to do is just try a few practice problems, and we will be online for live tutoring tomorrow if you have questions. So I'm going to write down these practice problems. We want you guys to give these a shot. So the first one is the natural log of x minus the natural log of 1 plus the natural log of 5 minus natural log of 2 is equal to the natural log of 3. And remember, natural log is just like any other log. It's a log with a base of e. So when we say ln, what we really mean is log base e. Okay? And then the second problem we want you to try is log base 3 of 1 minus 2 log base 3 of 3 is equal to 2/3 log base 3 of x. The third problem is 2 log base 3 of x plus 1/2 log base 3 of x is equal to 5. And the last one is this one. Log base 8 of n minus 3 plus log base 8 of n plus 4 is equal to 1. Okay, so give those a shot over the next day or two. Thanks, you guys. Take care.